Steep slope vineyards account for around 10% of the European viticultural land area and produce some of the highest value wines. Row sizes are quite narrow, typically between 90 and 150 centimeters. Currently, where possible, treatments are applied from a small tractor-based system that uses an air blast tool. Losses are high and ground compaction is a problem. A smaller robot-based system able to work in these steep slope vineyards is required. It should apply the irrigation product to individual plants in a selective way. Work in difficult environments. Work semi-autonomously. Work smart and safely. So, how to deal with this challenge? SARA project proposes an intelligent robotic solutions that will address the special operation needs in steep slope vineyards. Based on the existing Autonomous Robotic Platform for Agroforestry application ARPA, developed by SVMAC, the SARA Platform is equipped with an artificial intelligence system based on computer vision and machine learning techniques for the tailor-made treatment application to the grapevines, safely for plants and for workers. This robotic platform is stable on the slopes up to 55 degrees. The width is 140 centimeters, but it can be reached at 90 in phase 2 with easy readjustments. On the other hand, the weight of the platform is 1,800 kilograms, transmitted to the ground through caterpillars 30 centimeters wide, generating a pressure of only 0.2 kg per square centimeter over the ground. Moreover, it carries treatment tanks with level sensors and alert management. Finally, the solution is a hybrid platform that can work with diesel engines or electrical transmission. The platform is composed by an actuator with articulated arms, capable of applying product in a precise and localized way, both in conventional vineyards and in steep slope viticulture vineyards. The rigid arm can horizontally move by means of a hydraulic cylinder in order to regulate the distance between the leaves and the nozzle. The articulated arm has 3 sections, which allow reaching the leaves located at high levels until 6 meters reach, or the leaves of both sides located at the same level of the machine. Due to travel restrictions and other factors, developing and testing on real conditions has been practically unfeasible. In the absence of a closed real vineyard and taking into account displacement cost and logistics, the implementation of a simulated environment has been valued as the most convenient way to achieve simulated physical conditions. This allowed us to develop and test the workflow of both intelligent systems in a more agile fashion. The system takes the point cloud and the odometer readings from the sensor of the platform, mainly monocular and stereo cameras. Using this movement data, an estimation of the location is provided and used to transform the 3D point cloud into a 2.5D representation of the platform's surrounding shape, the elevation map. The system is able to differentiate between cross and occupied areas while calculating the orientation of the surface and its slope. Hence, defines areas that present steep slopes, holes or another type of objects are classified as occupied areas with obstacles. The intelligent system is able to detect a nearby obstacle within a predefined angle range. The proposed intelligent system gets the images captured by the camera on board the platform and processes them. In the case of detecting a grapevine, it returns an output which belongs to one of these classes: no leaves, low density, medium density, or high density. Then, this output is sent to the robotic controller to act in consequence. The system has 2 main stages. The grapevine detector is based on a deep learning technique for identifying the instance present in the image and providing their segmentation. The estimation of the leaf density is based on a machine learning classifier considering the mean value of the 3 color channels of the grapevine segmentation mask. The technical demonstration has been carried out in the Technological Experimentation and Innovation Center specialized in rural areas, which STIC owns on El Porreño farm. In the scenario, 4 artificial plants that simulate grapevines with different leaf densities have been arranged. The vehicle will advance along the path, placing the robotic arm with the actuator on the outer margin of the plants. To begin the test, the automatic mode is set on the vehicle, which induces a constant speed on it. As can be seen in the right margin of the video, the intelligent system constantly monitors the detection of obstacles and vines. As soon as a vine is detected, the nozzle of the robotic arm is activated, starting the application of the treatment. In parallel, the speed of the machine is reduced according to the density of the vine's leaves. The higher the density of the sheet, the slower the machine advances, thus achieving an optimal application of the product. The system advances by detecting each of the vines together with an estimate of its leaf density and adjusting the speed of the machine. The last vine does not have leaves, so the speed of the robot remains constant and the application of the treatments does not take place. Finally, a person stands in front of the vehicle to validate the detection of the obstacle detection system.